So our presentation will be on our product checkSTRESS. And so we go to the slide and why we developed checkSTRESS in the first place. Karthik, you are there?
I'm there, yeah.
Yeah. Can you go to the next slide, please? So Karthik is operating on behalf of me. Okay, why checkSTRESS? What is the reason we developed checkSTRESS? As you know, in almost all 3D, all plant design companies worldwide, nowadays they start using 3D plant design systems, where the 3D piping designers, they route the piping, considering mostly the space constraint and the process flow requirements, constructability, operability, and repairability, but they don't give as much importance to the flexibility requirements to reduce or absorb the expansion or contraction due to thermal loads. And so what happens, the as designed or as laid out system from the layout department goes to the stress engineers. They do the check on the stress and figure out that the piping layout is too stiff, and they suggest some layout changes. It goes back to the layout department and they make some rerouting of the piping considering other constraints. And this whole back and forth iteration goes on. And in the process, your project time gets extended. And in fact, the most stressed people I found are the pipe stress people. Okay, so let's go to the next slide, please. So then there's one more thing that's happening lately is to produce more output from the industrial plants to produce more goods, and also to improve the efficiency. Nowadays, the pressures are increasing, the temperatures are increasing. Now, once you increase the pressure, what happens to the wall thickness? You have to have a higher wall thickness so that to avoid any kind of pipe rupture. Then if you have increased wall thickness, that increases your pipe stiffness. If you have increased pipe stiffness and your increased temperature, of course, all the bending moments throughout the system go up, and thereby the thermal stresses and all the associated nozzle loads. So the designers definitely need a tool to check the flexibility up front and the resulting stresses and loads on the nozzle as they route the piping in 3D system. That's a requirement that's been there for a long time. And we actually developed and released checkSTRESS in 2010. We've been marketing it and we have been quite successful. And I'll give you more details on that as we go along here. What checkSTRESS does, it reads piping geometry, pipe sizes, material properties, operating pressures, temperatures, support types, support locations, everything from your 3D plan model. Then it takes that and creates a stress model, performs the flexibility analysis or the stress analysis, and creates plots and reports. What are the plots it creates? Stress contour plots for thermal load, weight load, wind load, seismic loads. And categorize them in blue, green, yellow, orange, and red. Blue means great, wonderful, everything is, happy. Okay. Green is acceptable. Yellow is on the, is still tolerable. Orange is on the borderline, and of course, red is a no-no. So now and we also provide, the checkSTRESS also provides a deflected shape for thermal load, operating load, weight load, wind load, and seismic load, so that the 3D piping designers physically feel what is happening to the piping in the real world. So that way they can route the pipe better, they can support the pipe better, and they can understand where they should locate the supports. And in addition, we also give what is called the status of resting supports. Let's say the pipe is in the design, it is resting on a steel support. We want to make sure during operating condition, the pipe is still resting on that support, not lifting off, so that the support takes the weight during operating conditions. Otherwise, you have a redundant support which is not performing its duty. You might as well remove it unless you need it for during shutdown conditions. Then it also gives you nozzle anchor loads, and you can compare against allowables to make sure the nozzle loads are met. And lastly, once the designer gives the location of the hanger and the type of hanger catalog to be used, it automatically selects the hanger and places them in the stress model and creates a stress model along with the hangers. So this is what checkSTRESS does. Now let's say once the checkSTRESS performs the calculation, let's say the designer looks at the stress plot, the contour plot, and the designer sees lots of orange and lots of red. What does he do, or she does? You have to make for thermal load, you have to make the piping flexible. How do you make it? You have to add bends and possibly loops. You may want to add some intermediate anchors so that you push the thermal growth in a different direction. You force the thermal growth to grow in the direction you want it rather than in the way it wants to go. And same way you can do with axial restraint. Now, in case you have orange and red zones, even in the weight stress contour plot, then you can add additional spring supports, constant support if needed, rod hangers, and resting supports. These are the ways that the designer does all this upfront to a great extent, so that when the stress model goes to the stress department, you can see the benefits now. What are the benefits? First of all, man-hours saved because the stress model comes directly from the 3D model. And if you re-enter the model in a stress software, you could have you may introduce some human errors there. So that's also avoided. Next is you can even locate supports, even if you don't have the support already installed in your 3D model, you can actually give a location where it is possible as a well point, and that well point is actually transferred as a node in the stress model. So the stress engineer knows that's a possible location for pipe support. Okay. Next, so effectively, by giving this tool to the designer, they come up with a flexible layout possibly with weight supports, and the layout is code compliant and nozzle load compliant. By doing this first level stress check by the designers, the iterative back and forth iteration between layout department and stress department is immensely reduced, reducing project cost, project duration, etc., etc. Now, we also generate stress reports, some sort of a sub-report from checkSTRESS, which they can give to their supervisor so that the supervisor can make sure the layout is flexible, piping compliance is met, nozzle load compliance met, the supports are all fairly well located before that stress model goes to the stress department. The stress department adds additional loads, like let's say water hammer loads, steam hammer loads, or harmonic loading, pump vibrations, any of those things, and response spectrum analysis, any of those things, they can add all the advanced analysis loads and perform the analysis and get detailed reports from the actual stress software. The next slide, please. checkSTRESS works on all these systems, by the way. We have a checkSTRESS module for E3D, PDMS, and Tribond. And a CADmatic is coming from Finland, which is a 3D plan design system. We have a checkSTRESS module for PDS, AutoCAD Plan 3D via PCF, AutoPlan and OpenPlan from Bentley via PCF again. And again, a Smart Plan 3D via PCF. CATIA, which is a Dassault Systems, that is again PCF. And there are a number of other software that produce PCF file, which are like SolidWorks, Solid Edge, CADWorks, ProCAD, etc. They also produce PCF, which can be read by checkSTRESS. So we have modules for each of these 3D plan design systems. Now we have gone, this is 2010. Now this is 2019, September we did this. And our flagship product is called CAEPIPE. Many of you may know. Now, just 3 months ago, starting October, November 2024, we have started replacing CAEPIPE with CAEPIPE 3D Plus worldwide. So there will be no more CAEPIPE as a standalone product to be sold. It will be always sold with CAEPIPE. And the data translators is not just for one 3D system. We are providing all the data translators that you earlier. All the arrows come with it. And the checkSTRESS works on all those 3D systems. So but at any point in time, you can use it only on one system at a time. For 1 month, you can use it on PDMS, because many of the big companies have PDS, PDMS, Smart Plan. They have many systems. So they can use the same tool on all those systems. And lastly, the hot clash works only with two systems, basically Aviva's products, E3D and PDMS, and Cadmatic software coming from Finland, where we actually take the deflected shape we compute using the hot clash, which is a mini CAEPIPE, is sent back as a reference solid geometry back to the 3D system, so that the 3D designers can check for interference during hot operating conditions. That's the key here. But that's available, hot clash is available only for Aviva's products and Cadmatic products. So with that, I think, what is the next slide, please, Karthik?
Yeah.
That's it, demo on checkSTRESS. My colleague Karthik will take over from there. He is our chief engineer in charge of engineering automation and products. He has been involved in checkSTRESS as well as in CAEPIPE and many of the 3D plan translators. So he is going to give a presentation on two different 3D systems, one online, one offline. Karthik, please take over.
Yeah. Thank you, Dr. Sir.
Yeah.
Thank you. Thank you very much, Doctor, for the detailed presentation about the checkSTRESS. Like Dr. Ranjan mentioned, let me go back to the number of tools, the 3D plan design tool where the checkSTRESS is working. Like he has mentioned during his presentation, the checkSTRESS works on all these tools. You can see that. And then some of the tools, it works online, like for instance, E3D and PDMS, the checkSTRESS works online. And for the other products like AutoCAD Plan 3D, AutoPlan, Bentley AutoPlan, Smart Plan 3D, all these systems, it works as offline. So when I say online, what do you mean by online? So it means as the 3D designers route the pipe, he or she does not have to come out from the 3D system, and they can directly launch the product as a plugin. Whereas when it comes to AutoCAD Plan 3D, once the designer is done with the layout, so they have to do a file creation, which is they need to export the stress layout as a PCF file, and then feed that PCF file into the checkSTRESS. So now for our presentation, so we are going to be using two tools. The first one is an E3D, which is coming from Aviva, where it is going to be online. Then following that, I'm going to show you the same checkSTRESS working on AutoCAD Plan 3D. You will see them one at a time. Let me go now to the actual presentation. What you see on the screen is Aviva E3D. Now you can see the designer has already done the layout of the piping. It is going from, say, this pump and another pump here, and it is going and connecting to the equipment nozzle here. This is a suction line, you can see it. And if you see here, inside the Aviva, you can see there is a plugin. You just click on this plugin, it brings the interface for you. So where you can just feed in the basic information. It's all self-explanatory, where it is just asking you what is the starting node number you want to have in the checkSTRESS, and what is the node increment you want to have, what is the analysis code. In case we use the hangers, what is the catalog, and then it is also asking you certain basic information like the pressure, temperature, and the weight, in what unit you're going to be using it. And then you can select the system from the 3D design. So let's say now the designer is actually doing the calculation now. He's just selecting the line. This is the system we are talking about. And he just says apply. And if you see here, you're not coming out of the tool, you are running on top of that. Now, if you see immediately, the designer is seeing the result, not in terms of numbers, it's all only the color coded graphic. Like Dr. Ranjan mentioned, it's all shown in terms of blue, green, yellow, orange, and red. Now, designer sees there's some red here. So now, for them to know why there's a red zone here, we are giving them what is called the deflected shape. Now, let's say when you click, what is happening on the expansion deflected shape, and if you animate it, now the designers can understand the pipe wants to expand freely here, but this nozzle is not allowing the pipe to expand freely. So now the designer knows that you cannot do anything here. You have to go back to the 3D system and make layout changes. And then again, see what happens to that. So just going back. Now let's say he has already done the revised layout. I'm going to remove this and assume he has come up with a revised layout because he sees the entire 3D model and he knows where the concrete is, where is steel, and where the other objects are. So now if you see here, he has brought up the revised layout where the initial layout was going directly from here and going and connecting to this. And instead of that, now he has actually added a T-joint here at the middle of the pipe, and he has added just a bend. By doing this, he has just made this entire thing more symmetrical. Now in the process, again, when you do the check stress, you can see that it gives you output so quickly. Now he sees everything is blue and green. There's no red. Now again, you can see what is happening to the expansion stress. You now can see it is freely growing without any problem. So now, since he has already solved the expansion, he can also see what happens to the weight case, which is a sustained stress. Now, if you see again, it's all blue and green. And since you already have these support, you can also make sure what happens to your earthquake, the seismic, and again, it's all fine. And once he solved the stress related issue, then he can see what is happening to the weight support. For example, in case if you want to do some maintenance, he has added a resting support so that when you disconnect this nozzle, still the pipe weight is carried by that. So which means it is acting more like a temporary support during a maintenance activity. Now, since he has added the support, you can also make sure that during operation, the pipe is resting on that support. How do you do that? Here you can see there is a status of resting support. So when you click on that, it is saying it is reached. And you can see there is a load acting on the support. So the pipe is sitting on this, and hence you have a load here. Now, similarly, if you want to see the nozzle loads or the anchor loads, so you can just click on the source summary. It is giving you these numbers. And once it's all done with this, let's say you want to give it to your manager for approval. You just give a quick report and you click on print, and then you can say preview. Let me go back. And here there's a print. You can see it just selects whatever is quickly needed. And when you click on the preview, it just gives you a nice tabulated report. And if you go to the initial of this document, you can see that it gives you the top 10 nodes for all the 3 cases where it is saying highest efficiency.
Any
And
questions?
once
No. Okay. Go ahead. Proceed, Karthik.
yeah. So now once it's all done, so the designers can now save this and transfer this model to the stress department. So how do you do that? So you can now say save as, and let's call this as suction line, and then save it, and the designer has done his job. So that's how it works on the E3D. Now let's go into the AutoCAD Plan 3D and see how it works on AutoCAD Plan 3D. Now here is the layout again. And for this presentation, now we are going to be taking a line which is going from this equipment nozzle. You can see that. And it goes and connects this yellow line, goes and connects the equipment nozzle here. So now let's say if you see the designer has already laid out even the supports here. For example, he has put a support where it is not only stopping the growth in this direction, also in this direction. So there are 2 lateral directions. It is actually stopping the pipe
So
and
it's
not
more
carrying
like
the
a
weight of
guide
more
there.
like
It's
guide
guide.
here.
Basically, it's a clamp there. Okay.
It's a clamp. Yeah.
Yeah.
So he has put a
Resting support with a clamp. Yeah.
Now let's see what happens here. Now in this case, what you do is, as I mentioned to you, so you will have to create a PCF file, piping component file for the involved line. So this is the system name. You see, this is the system name. You can just push that. This is the file creator. I'm just moving it to your folder. Now you run your checkSTRESS.
You're running on checkSTRESS now.
Yes. Now you can see this is what the same interface again. But instead of inside it is running from the outside. You just select the PCF, and then again you can fill in the basic info. Now again designer is doing okay. Now again he sees lots of red here. Now why there's a red here? Because he has put a clamp Basically, due to temperature, the pipe wants to expand, grow in this direction, but these two guides are not allowing the process. You can see that the pipe is going up and putting a lot of bending moment here and creating high stress. What do you do? So you go back to the 3D and make change.
So the clamp is not allowing the pipe to expand, the two clamps.
Yeah. So now again, go back to the 3D. Now let's say he has done the revised layer. That's the layer. And I'm bringing the revised layer. Now this is the revised layer where the designer has replaced.
He removed the clamps.
Yeah, he removed the clamp and just put a support where it just carries the weight of the pipe. Just resting on it.
The resting support was already there. Yeah, okay.
So now he has done that. Now let's see what happens. Now again, you go there. Now again, create the PCF file. This is the revised PCF file. I'm putting it here. And now you can select this. And again, now again, designer is doing this. Now you can see everything is blue. Now it's happily growing. And now again, you just see what is happening now. It is freely growing. It is not stopping the expansion. At the same time, these two supports are carrying the weight of the pipe. Now, the moment you put a resting support, it automatically opens up for you to ensure that during operation, the pipe is resting on the support. When you click on that, you can see it is reached. Now, let's see what happens to the weight case. Now, you can see this red and orange here because you don't have any support here.
There's a long overhang there. Okay.
So again, you can see the reflected shape.
Yeah.
Now it's all overhanging, and that is what is causing the constraint. Now what do? You go back to the 3D model and add a couple of support here and also a couple of support in this line. So let's say again he's going back to the AutoCAD and assume again he has done the reverse layer, and here is the layout. And you see here he has added couple of more supports by looking at where the steel and concrete is. There's one support here, and he has added another support here. And then on this direction, he has added 3 supports. And let's say he knows where the steel is, where the concrete is. And in case during the detail analysis, if the stress engineer wants to move the support or delete the support, he or she should be knowing where is the possible location. Now again, for that, as Dr. Ranjan was mentioning, what we can do, we can add additional points. For instance, here there's something called add weld to pipe, and you can say just adding it here. So by doing that, now you're giving indication to the stress engineer that in case if you want to move the support, you can move the support from here to here, or maybe from here to here. So just added a weld point, but there's no support here. Now, since you added this, when you create the PCS file, you will see that, like Dr. Ranjan was mentioning, it will be transferred as a node point. This is the file. I'll select this again, and now the design is doing it. On checkSTRESS. It's so quick. Now you can see, even though he's added all the support, it is really not interfering with the expansion. So everything is still blue and green, and you didn't create an issue by adding additional support. Then you can see the weight case, it's all fine. And now, as I said, when you go to the edit layout, you can see that it has brought an additional node here and also additional node here. So the stress engineer knows in case if he wants to remove this or move it to somewhere else, these are the 2 locations that it is possible in this line. Now let's see what information it has brought in from the 3D design system. When you click on material, you can see all the properties directly came from 3D model.
It's all coming from 3D systems, from AutoCAD Plan 3D.
Not only that, any 3D plan design, you will get all the information directly from 3D. Okay, all the weights you can see transferred. All the plant weights are all transferred. And you see there's a welding key somewhere. And you can see these are the different loads. Everything you can see. Now, since he has done with this, he is now transferring the model to the test department. He is calling it final. And the designer has done his job, where he has transferred the code compliant layout to the stress department. Now the stress department can run this independently on CAEPIPE standalone. Just open that file now. So let's see, this is the what we just created now, final, and the same interface with all the supports. Now let's say he wants to try with adding seismic. I'm just giving 0.3 in the 2 horizontal direction and 0.2 G in the vertical direction. And he just adding this and performing the calculation. He's not done anything. He just added the additional load, like Dr. Ranjan mentioned during his presentation. Now you can see still everything is all fine, no problem. Even occasional, they're all well within the limit. Now again, if you see the support load summary, it's all giving for all the load combination, what is the minimum, maximum. If you input the allowable loads, then it will qualify and tell history whether it is meeting the rules or not. And similarly, you can see all the element sources, each element wise, again for this is load cases. When you've done it, if you want to print the report, you can select all of them, and then say print the file. It just gives you nice tabulated report, including the bill of quantities, and also it gives you in the table of contents. You nicely download it you get.
Okay, so that is
So
that completes your presentation, Karthik?
Yeah, this completes our presentation. Now let's go back to the PPT.
Go back, please. Yeah.
And then now let's just want to summarize in terms of the benefits.
Yes.
Like Dr. Ranjan said during his presentation, one is by using checkSTRESS, what are the benefits you achieve? One is you save a lot of man errors and avoid human errors because you're generating a model directly from the 3D plan design system. Then, as I was showing you, in case if you want to add the possible support location for the stress linears to know, you can create well points. You just saw that. And those is going as a nodes in the stress model. That means stress linears jobs become easier rather than going back and forth and reading all the drawings, 3D systems and all that. He doesn't have to do that. Then again, since the tool is handled by the designers to start with, the whatever layout they are coming up with and giving to the stress department at the end, it is already code compliant, and also it is meeting the nozzle loads and the anchor load criteria. And then by doing all this, you are basically reducing the iteration between the stress department and the designers department, which is going back and forth in a conventional. And then as we showed you, the designer can also generate a quick summary report to get approval from his manager before the final model goes to the stress department. So with that, we are concluding our presentation. If you have any questions, you can ask.
Karthik, can you show the 3D translators, all the various arrows you have? Can you show that slide? Yeah, the previous slide. Yeah, this one. Yes, this is the one. Yes. Now, the checkSTRESS modules, we have independent modules for all of these 3D plant design systems. So what we have done starting September 2019, we all the modules, we call it data translators, along with the checkSTRESS that works with these data translators, combined all of them in one massive system. Can you go to the CAEPIPE 3D Plus? It's called CAEPIPE 3D Plus, where it has all the checkSTRESS modules, all the data translators, whatever we have in our bag, and also the totally independent CAEPIPE. So CAEPIPE with all these, and that's we call this whole bundle package as CAEPIPE 3D Plus. So that has been there since September 2019, and since it's mature, working worldwide without any hiccups. Now we are replacing CAEPIPE all over the world with all our users with CAEPIPE 3D Plus. Those who have been on maintenance, they get it without any upgrade fee. Those who dropped out of the maintenance, annual maintenance, they had to pay an upgrade fee.
GVR, is there a way? What if you have a Caesar 2 shop? Can they use CAEPIPE?
Yes, we do have a translator.
Okay.
We have a two-way translator. We can read Caesar 2 models. That's one way, which is built into our CAEPIPE 3D Plus as part of CAEPIPE.
Okay.
And we also have a translator to take the actual model file, the final model file from CAEPIPE into Caesar 2. That is not built in. That is an optional priced product.
Okay, so you're not bound to using K-pipe stress analysis.
No, we are not bound. We are not bound because I mean, we can't.
you-
Some of the, I mean,
You
we
can
can't
implement you can implement this for your piping designers and not be bound to using K-pipe. You can
exactly.
keep using auto pipe or Caesar 2 if you want.
Or whatever it is, whatever the XYZ, whatever they use, they can use.
Right, okay.
Yes.
Yeah.
So we are not bound by, we are not, wherever the money comes is what matters, not, we are
Yeah,
not
some people
emotionally attached.
some places they want to use their stress and they don't want to change, right? So at least
Yeah. I agree with you 100%. Not easy to change people.
yeah. But at least this way you can get
No, even though I know Dave
preliminary
Deal is
stress
there
relief.
as attendees. Dave Deal is a,
Yeah.
you know, he used to be in charge of Caesar too. I think he was, I think Dave, you're still there?
I'm still here. Yeah.
Okay. You're still with the Intergraph or Hexagon now?
Oh, I'm retired. No, I'm just
Oh, you're
interested in
retired.
what you're
Okay.
doing. Yeah.
I'm not retired. I get only tired every day.
Yeah.
Yeah, David was on the SPED board for what? Was it 4 years, David?
Oh no, a very long time.
Yeah,
Way
yeah,
back.
okay.
Oh,
Half a
Dave,
century. Yeah.
Yeah,
Yeah,
I
David's out
mean,
of
just
it.
the recent time you were here for 4 years, but before that,
Yeah.
you were on with SPED.
I do have a question though.
Yes, please. Yes, Dave.
You're reading the PCF. Now, if I have a PCF, I might have a nozzle connection, but I don't know what the thermal growth of that nozzle is. How do you get that information into the analysis so that if you have a nozzle that is growing, that
Yes.
growth ends up in the analysis?
Yes, okay. Karthik, can you handle that?
Yeah,
If they have it in the PCF file, can they include that in the PCF file?
yeah. To customize the PCF file to include that information, then it will also bring you the information that what you're looking for. Okay, let me show you. And we do have a sample. For example, if you go to the PCF file section here, and if you go to the end of the section, we also talked about how do you bring the allowable load and also the thermal anchor. You can see it. It is described here. And then I'll show you one sample. How
Sample
does
is
it work?
better. Sample is better.
So that we can see.
It's like appended to the PCF file.
Yes.
Yeah, basically you customize the PCF to include anchor moment, thermal anchor moment, then it comes in automatically. Other option is inside checkSTRESS.
Okay.
Can you move the graphics to the left side
Yeah, let me
or move it, at least move the window a little bit?
show you. So
I
you
think
can
this is
see.
the one. Yes.
So it will automatically bring the thermal anchor moment directly from the PCF file into your checkSTRESS.
So that was added. That was another attribute that was added from a previous analysis. You have to move the data to the new PCF.
Yeah, so in the PCF file, when you're actually creating that, let me open the PCF file for you and show you.
If you open the PCF file, you'll be able to see it.
Yes.
The PCF file itself is somewhat customized. And we tell in the manual, we clearly write how to customize your own PCF.
Yeah, I remember that stuff. Yeah.
You can see here.
Okay. Yeah.
So these are the information that you are transferring. You're customizing the PCF from your 3D plant design system, and that can be brought in directly into your checkSTRESS and also the K-pipe.
So it's not just push button. You have to be pretty rigorous in keeping track of all this stuff, and it can save so much time. So you better keep track of it, though, right?
Yeah, the more information you put in, the more time you save.
Yeah.
Yeah.
And it also goes downstream, so you don't need to re-enter the data once again.
Well, I'm just hoping it gets entered in the first place. Yeah.
Yeah, I mean, the whole idea is to have a seamless transfer of data from all the way from the front end of the plant design to the, until you dismantle the plant. Okay. That is that's the best you can have, is to have a seamless transfer all the way.
Yep. Very good. Thank you.
And if you see here, it is actually you didn't do any customization here. It is just direct whatever the model is already available. It is having all the information that is needed where you're not forcibly putting anything here. So because of which automatically everything gets transferred. We are not feeding it in. Only the thermal anchor movement is a special attribute that generally you may not have it. So in such cases, you can feed it in and that can be transferred to checkSTRESS.
Of course, Karthik, you can also add that by editing the checkSTRESS model itself. Is that correct?
Yes,
Yes.
that also you can do. If you don't have them and if you don't have the customization done,
Let's say
you
you
can
later on compute that manually and you can add that.
yes. See, that's why one of the reason, if you notice here during my presentation, there was always a button called edit layout. For instance, let's say you take this and when you do the analysis, you always have an option to edit the layout where you can go to anchor and you can always add anything you want. Let's say you also want to the X direction, you can do that.
Yeah, we want to reduce the amount of work for the designer. We don't want designers to get into the nitty-gritty details. The whole idea is you should, when the layout goes to the stress department, we are not trying to replace the stress engineers. We are trying to make their life stress-free.
Any more questions?
Yes, please. Hello?
Yes, Mr. Abed.
Do you hear me? My name is Tabit. I'm attending from Montreal from Match. I'm impressed by your presentation. It helps too much either for the critical lines that are going to stress engineer it, minimize the amount of iteration.
Yeah.
And also with the non-critical lines, also they can be better designed. It is not left to the guess of a designer or an engineer who is not really expert in stress analysis. My question is, I'm thinking if you can make a presentation for our team. I don't know where you are based, in which part of the world you are based in India?
We are based in two places, California and India, two opposite parts of the world.
Okay, so
I mean, for our clients in Asia, Europe, we can handle from India. For
okay.
our clients in North America, we can handle from Pleasanton, California, and South America.
So I'm thinking to maybe to arrange a presentation to our team. Is that possible?
Yes, please. It is possible.
I would like to get your information, email address or phone or something like that.
Yeah. Once we have, how do we, Karthik, do you know how to take, how do I pronounce your last name, please?
Tabit.
Tabit. Okay.
Yeah.
Can we take Tabit's email ID? Or
Okay,
my email ID is the easiest. Okay.
Yeah, email ID is the
My
easiest.
email ID is the easiest. GVR, G as in George.
If you can you write it on the chat, please?
Yeah, can you put it in the
Karthik,
chat?
can you write it, please?
Yeah. I'll do that.
Okay, he's going to do it.
Okay.
So
that's my only question.
Yeah, we can have a presentation one-on-one with your colleagues at your company.
Okay.
It's in the chat now if people would look there.
Thanks a lot.
Yeah. Have you given you're writing it, Karthik?
I've already given.
It's
done.
Yeah.
Done. Okay.
It's mentioned here. Any further questions?
I had a quick question. Sorry, I was called away there. I mean, I'm not sure if this is redundant or not, but is there a bulk load for the process data, wall thickness, all that kind of information? Can we connect this to an LDT somehow and map some spreadsheets in there so you can just preload all your process data for the designer?
Okay, good
Or
question.
are you kind of manually entering in line by line?
No, you don't need to do that. If you go to our actual product, let me show you the user's manual.
I apologize if you already dealt with this one.
Not a problem. So if you actually go to this section here, for instance, when we talk about the reference section for the PCF or for that matter, any 3D plan design system, here we have listed out all the details in terms of what information is read from what attribute. For example, if you see the PCF file, a lot of times you may not have the thickness defined. And as you said, it is all managed through some sort of a mapping database. You can see that there is an appendix C. As you go to the table of content again. And if you scroll down, there is an appendix C, which talks about the schedule table, and where you are actually creating this kind of mapping at the back, where you're saying in English unit, what is the nominal size? And in case if you're using metric system, what is the nominal size? Then the corresponding outer diameter and the thickness. So once you feed it in and store this inside your software, and if you put this in the central location, it will take automatically for all the projects on here.
So
For
this
the
is more like a mapping database for you.
Yes, if you want to use it. If you don't want to use it for this, you can just feed all the information directly into your system and go for it.
Okay, I guess my question was, can we avoid some redundancy here, and capture, because on your LDT you're going to have your line class, your material, wall thickness, pressures, temperatures,
Yes.
etc. Yeah, you'd need ambient conditions as well, I would assume.
Yes.
Yes.
So is there a way to cross-reference that to existing information tables? Or
Yes.
do we need to kind of create this from whole cloth again?
No, see, one is in the 3D plan design system. Like for instance, if you go to the properties here, in
Right.
the line, you already have all this information that we are directly reading. For instance, if you come down here, the process line, you have the temperature and pressures.
Okay, so that's all going to be done within the software, like the parent
Yes.
software, and then you
Yes.
link to that directly. Yeah.
Correct.
Yeah, basically, whatever, you can add all that information into the 3D system. It's better to do it like that. So
Yeah.
it's central database, it carried forward all the way.
So you can see here, again, the weight is already input here. So it is directly coming into your 3D stress analysis.
Just have to make sure your designers are keeping all that information up. Lots of time they won't bother to enter that. Or we
No,
won't
the
be
more
linking
they
that
enter,
data.
better it
But
is.
those
If they
3D
don't enter,
models
then-
won't necessarily contain all that information, and they'll dump it over to the stress guy to plug in the spec and do all that, right? Didn't park it all in Caesar.
Yeah.
So I can see where this is would need some changes in work practice. Again, any data rich environment, you're only as good as your data, right?
Exactly. Yeah.
Exactly.
That's true.
So
designers
are going to have to be much more familiar. It's going to need a pretty competent semi-senior guy to be able to get in and make sure.
Yeah. In fact, the project manager should take the lead in this to create that ease of transfer of data from one to the other.
Make sure that practice is adhered to.
Exactly.
Yeah. It's another level of checking for you, Kevin.
We thought we are saving time and money, but like we're adding work now.
Yeah. Anytime you add data, you add, and then you add errors and everything else, right? So.
But downstream, you're going to save a lot of time.
Oh yeah.
Yeah.
Well, and I think just educating the designers live and having them figure out and make the changes, that's huge. I see for this, like designers going, oh, okay, oh, gee, that's what happens. Because you dump it out to Caesar and you get some comment back from the stress engineer and they don't necessarily really take that into account. But here they're going to go, oh, okay, all right. And then they got to figure out how to solve it for themselves or get somebody to give them some input. And then the next time they do it, they don't maybe don't make that same mistake, right? And they come up with a cleaner design. So I can see this as a great learning tool.
Yeah.
Yes, it is. It is a great learning tool. They they feel how the piping responds to various types of loading, which is good for them.
Yep.
So they'll come up with a better design, much better going forward.
Lately we see more and more companies actually is more interested and they are willing to input all these information into the 3D system because, as you said, they save a lot of time and the cost downstream. We see a lot of clients are showing more interest, and in fact, they are doing it. They are going out of way, and then they are forcing the designers to input all the data that is required for stress analysis, and that's a good news for us.
Dave, any more questions from you?
I think David he had to leave.
Oh, I see. He left there.
Yeah, he's retired now. She's got many, many things to do.
Yeah. I thought he was retired.
Yeah, he left about 10 minutes ago or 5 minutes ago. Yeah, not even long ago. Yeah.
Any
Okay,
other questions, ladies and gentlemen?
if there are no further questions, then I guess we can start closing this down.
Juan, you
Ye-
have a
Yes.
question?
Yeah,
There is
how
a
are
You
hand.
have a
you?
question. Okay, good.
Yes, sorry, I will lower my hand in this moment. Excuse me. But yeah, I think it's the same that Bruce was discussing with you. Yeah, we will need to be sure that the designers include all the information required to extract this PCF and do that little check in order to have some feeling about the behavior of the pipe. For example, I am thinking about the supports. I think that we will need to be sure that our designers has all the supports, all the library of supports with all the determinations included in the system, in the 3D model system, in order to, I mean, the checkSTRESS tool to be sure this is a guide, this is just a rest support, this is an anchor, etc. So yeah, I think that we'll need to be take care of that, and the designer will need to be very, very, very care about it. And my other question is, which code is handling these results? I mean, you made some checks, expansion, sustain, occasional, but it is related to which code? B311, B313?
No, we have all the codes. Can you?
Okay, it
Karthik?
depends on the system that you are checking.
Yeah,
Yeah,
it could be
you can-
European
you
code,
can-
it could be Canadian code. We have 43 codes there, but I don't know how many codes are there in checkSTRESS.
Okay,
Yeah,
but
all
again,
codes.
31.4.
okay, but
Whatever codes you have.
Yeah.
We
this
even
definition
have,
came from the database of the
Yeah.
3D model, or
Yes,
okay,
yes, from the 3D model, yes.
okay. Anyway, yeah, the 3D model requires to have all that information very,
No,
very
no.
detailed.
you don't have
No,
to,
no.
you can
You
input
don't
that
have
in
to. See,
checkSTRESS, but the whole purpose is the designer
here.
should, as much as possible should come from 3D.
Okay,
see,
Yeah, the code is
See here, you
selectable
can-
though. Right?
yeah, you can see here piping code for analysis. You can just say
Mhm.
modify, and then it gives you the complete list.
It does,
okay.
further to Juan's point though, how do you understand what support, like if there is a guide or an anchor, how is that determined? Are we loading in pipe support codes? Is there a pipe support library
Yes.
within the parent software that this
Yeah.
that this is
Yes,
the checkSTRESS is
yes.
reading, and it
Yes.
understands, and if I
Yes.
have a guide in a certain direction, how is that does it
Hmm.
just read the geometry, or?
Yeah. For example, now you see here, this is a kind of support where it is stopping the pipe moving in this direction and also the vertical direction. And there's a 2DM support with stanchion. And if you see here, there is an S key, which represents the type of support. So what we have in the backend database is already customized based on whatever catalog that is built into the AutoCAD Plan 3D. We have taken the complete catalog. For example, if you go to here, see all these catalogs are there, right? And each of these catalogs has a SKey built in. And corresponding to that
S key, okay, S key.
Yeah,
Okay.
symbol
yeah.
key,
Yeah.
symbol key, and corresponding to the symbol key, we have already stored that information into our database.
Okay, so it's already married up.
Yes. Now here, if you see here, if you open this, you can see this.
Yeah, and earlier you were mentioning that you don't have to place a support. You can place a potential support location if you
And then
don't
just
know.
key in a node, right? Yeah.
Yeah, you put in the node, and then in theory that can be
Yeah,
decided
you just
later.
give a well point and it takes a note there. But what we are saying is we are already converting many of the stuff from here, in this case, AutoCAD Plan 3D, into the corresponding mathematical support inside checkSTRESS.
Yeah. So because
And
of
if
which
I
it
was
will
to have
automatically.
if I was to have a base support like on that control set, for example, with a guide, how would checkSTRESS read the orientation of the guide? Would it know it was restrained in north-south or east-west? Does
Yeah,
it pick that
so
up from
that
the
is why-
geometry, or?
Yes. Now, if you see here, there is a whole list of tables given here, where if you go to the end, they're summarized. Now you can see here, these are the information for different type of supports. and it is giving you what should be the information that you're supposed to feed in, like stiffness, gap, in what direction they are, global, and if it is local, then you can say the local axis of the pipe, axial, shear Y, shear Z, and if it is single acting, then you can say it is acting in plus X, plus minus X, and the
Okay, so
syntax
you
are
can
all
just
different.
detail that in through the input.
Yes.
Yeah.
Yes, exactly. So you just corresponding to the kind of support you have, you put that information here.
So you
And
can
this is your-
actually customize this particular table on your own.
Yeah. If this is the simple keyword you saw there, like we saw duct, right? In AutoCAD Plan 3D.
Yeah, I saw duct, yes.
Yeah.
Corresponding to that, now you're saying it is a guide.
Right.
And where you're saying the stiffness of the guide is rigid, and there's no gap, you're saying, and there's a friction.
I see, yeah.
point.
And the friction coefficient is 0.3.
Yeah. So this is already put in, and because of which, when you do the translation, it is automatically bringing us guide support for you.
You can go to the CAEPIPE, the corresponding checkSTRESS model,
See now.
and it shows there, that particular support,
Okay.
the guide. Which guide? We don't know which guide.
All
Look at
guides.
all the guides. Okay, there it
Click
is.
here, you can see.
It's come from directly from AutoCAD Plan 3D.
You can see resting support. See here, these are two resting support. The parameters are all there, and you can see the direction also mentioned. Which direction?
Direction is global Z.
So it takes care of that. So we have already done all those, and in fact, number of nuclear plants use this for your information.
The biggest user for this is Electricity de France, which owns almost 54 nuclear plants in France, and for all their future generation nuclear facilities, they use checkSTRESS
on their E3D system.
On right? Aviva's E3D?
Yes.
Yes, okay.
They've been using it for several years.
No, yes, exactly.
It's all well tested and qualified. So as you start using it,
there's a detail, actually, Karthik, there's also a detailed verification. There is no verification report for this, correct? Only for CAEPIPE, we have a verification document, but we must be having some amount of verification here. Basically, the analysis module of checkSTRESS is nothing but CAEPIPE, a mini version of CAEPIPE. That's all it is. Yeah, basically, we just close all the windows designers don't need to see. Okay, and keep only those windows which are required for the designer.